Okay, so when we use QEpy, one of the application that we directly use ASE. ASE is Atomic Simulation Environment. It's one of my best favorite package because it's very powerful. You can play with some items, play with structure, or you can write some interface to ASE to make ASE to use that calculator run dynamic, relaxation, anything you want. So ASE already have many interface to almost, I remember, 30 package. So because ASE is a Python code, so another like natural way, we just write a Python interface to it, directly called the QEpy. So we have this QEpy calculator. So the way you use it, you still give an input file, and this from file means that we didn't give the items, and these items we will read from the file. And otherwise, we have another way called use ASE to build ASE items, and you do the ASE items. You don't need to from file to get the items, and you can from this calculator get potential energy, force, all these functionals. So how do we use it? So this example to run the dynamic with ASE. So not only for QEpy, for all the interface, we also have DFT code, or you want to use. They already write in some cast step, others based on the file, not on our memory way to interrupt. They also have many calculators. So the calculator, you just give a different calculator, but the code will be the same. So when you run the dynamic, so we just put the QEpy calculator here. That's the right line we here. We give a QEpy calculator, give a communicator, same as before. If we want to run the parallel, and we give an input file, and we will run the rest step, build the items. So now we see we don't need to from file to get items because we can use ASE to build items or read the file, get items, and we set calculator. The rest part is just a dynamic way. We need to initialize the velocity. We give a thermostat. Sorry, and we also, yeah, this is just a very powerful the Python way. You can build the trajectory and define how many steps you want to write the snapshot. And you also can, this touch function can make you control, you want to write something or you want to print something up to several steps, and you can define anything here. Or when we want to when we want to run the QE, we want to get wave function, we want to save wave function after several steps, or we want to save density after several steps. We also can write a function and to attach to the dynamic, and we can do what we want. And another way that we can run the relaxation. So that's also very easy. You just from ASE import the optimizer, and normally we use RBFGS, and you just run it until converge. So here's mistake is Fmax, because I just copied the code from left. So Fmax is I should fix that to not miss anything. Means that the maximum the force will be until this one will be converged. So that's all you give how many steps you run. That's the way you control how it converges.